All right, percent change. Your book talks about two different methods of doing this, but there really is only one method. The other one's just a shortcut because how much is this worth? 1,000 million points. Okay, so first problem example. Huh? No, I'm not going to make this one. Although it will be, I should make up another quiz. Eh? Okay, A, by what percent did the ticket price increase from 2014 to 2015? So 2014, 2015. Let's see, 2015 is right about here. And into 2014, it was, let's see, 96. She's here. I think she's wandering around with she does a lot of her sped stuff in the morning. So I got $99. I always like to take the high price first. $99 minus 96. So it had a $4 increase, right? They want to know by what percent it increased. So we take, let's see, $96. So there's where it was. We need to do a times it by a percent. Where it went up $4. So we should multiply it by 1.04. And that should work to 99, right?
He said this was really easy. It is. Did you hit record?
I think so.
Well, you have to record it. Dismissed last week.
Yeah. Dang.
Well, you know, I think that's wait, why do you want to
Yeah, I was just thinking this is what we increased it by. So we want to take 96, not multiplied by 0.104. Uh,
Oh my god.
yeah.
point for it, right?
Well, it's less than $4. Um,
Isn't that $3?
yeah, it's less than $4. It's $3, right?
He's in his coffee. You're like, I'm 11.
So we don't know the percentage increase. That's got to equal 99. So we got to divide it, not multiply. My fault, big shot. 3%, 3.1%. Well, solve for x, right? So you have to divide both sides by 96. We don't know. This is the percent. I'm letting x equal the percent of increase, right? It's an unknown. So if I take, and this is the new price, this is the old price, going to divide both sides by 96.
So you don't have to do 99 minus 96 at all.
No.
All right.
So our percent ends up to be 3.1%. Okay, use your answer from part A. Oh, I guess it is part A. To forecast the ticket price in 2016. So we're going to take our $99, 2015 price, multiply it by our percentage increase, 0.031. And actually, now this time, if I put a 1 there, it'll automatically give me the price. Or you can do it in two steps. I'm doing a shortcut. 99 times 1.031 So my ticket price in 2016 is going to be 102.07. Do you guys get the shortcut, or should I do it in separate steps?
Hmm?
Want me to do it in separate? You guys look confused. All right, here's what I did. Okay, I took the 2015 price of $99. I multiplied it by our percent increase, which is 3.1% or 0.031. That equals times 0.031. That equals $3.07. Okay. Then I take my $99 here, add the $3.07. That's how I got the 102.07. So instead of doing it in all this work, I just put, well, here's the 100%, and then the additional 3.1%. So I just multiplied it all at once. Either way, you're going to get the same answer. Okay, next one. Between 2000 and 2015. So here's 2000. My price of ticket was $43. And 2015, the price was $99, right? What percent did the ticket price increase? Again, we have to, we're going to multiply the 43, the original price, by some number, right? By some number, we'll call it X, and that's going to equal $99. This is my percent increase. So I'm going to divide both sides by 43, and that will equal the percent increase. See 99 divided by 43, and we got a 230% increase. Yeah, more than doubled, right? Oh, speaking of coffee, that was a true statement, by the way. I didn't break it down farther enough. All right. As you work through this section, think about these questions. Can you increase or decrease? Blah, blah. Is 200% increase the same as doubling or tripling? Um, I know 200% is. I would think 300% would be. Do you know why the changes are often stated as percentage change? Because that's what people care about. Let's begin by looking at ways to increase a number by a percent. If we want to increase 25,000 by 5% in two steps, see your book breaks it down between two steps and one step too. If you want, you guys know you got a book, right? By the way, did you go home and do that?
No, I forgot to.
You, how about you, Juan?
I had a game. Yeah, that was awful. We should have like 20. So it was 10-6. I think the final score is technically 10-5.
10-5.
They scored more than that last game with Company. So technically it was back. Oh,
Okay, so the two-step method is you multiply 25,000 by 5%, which they did here, got 1250. Then take your 1250 and add it to your original amount to get 26,250. Now, the easier way to do this, save yourself some time. You got your original 25,000, right? You're going to multiply instead of 5%, multiply it by 105%, 1.05. Okay, that way it automatically adds it in when you put it in the calculator. I bet you we'll get the same amount. So 25,000 instead of just 5%, we're going to multiply it by 1.05, 105%, and there's my 26,250. Looks like I accidentally put a negative sign in there. So I think it's easier to do it the one method, but if you want to take your time and do it two methods, all power to you. All right, the following picture verifies um, that our answer is reasonable. I'm not going to do that. Oh, by the way, that 105, that 1.205, that's called the multiplier. Okay. Example one. Uh, yes.
That's what happened a lot lately.
Yeah. Maybe it's because they're trying to fix the clocks. Get it? Oh, speaking of which, they fixed the clock.
Well, I don't think so.
Wow.
4 days.
All right. Let's just go on and do some problems. Increase by 22%. So we're going to do the one-step shortcut method. Find the multiplier. The multiple. Oh, geez, they don't even have a problem. The multiplier is going to be 1.22, right? Here, decrease. All right, be careful here. What are we going to multiply our principal by to get it to? Be careful. If we're going to increase it by 22%, we're using 122%. If you want to decrease it by 22%, what's going to be your multiplier?
We're increasing
To save ourselves a lot of work.
so if it's decreased, we're going to just 22. Pretty negative.
I like your thinking on it. Okay. What did we do? You start out with 100%, right? So 1.00. That's what we did here. Then we're increased by 22, so we're going to
Oh, yeah, I get that.
add 22. What are we going to do here? Subtract
Oh,
22, right? So it's going to be 88. Our multiplier is going to be 78, sorry. 0.78. Get it? Be careful with that.
So we're just always putting at 1 and then just adding.
Yeah, one decrease, you subtract that percentage. Increase, take one and add that percentage.
It's like from 100.
Yeah, from 100. Think of it that way. It's a lot easier to do these problems if you get the multiplier and don't have add this, add that. Um, yeah, I'm not going to go through this. I pretty much did with the examples. Number three, at your job, there are two proposed pay raise structures being offered by management to the labor unit. Option one, you get a 5% increase. Option two, you get a 3.5% increase, then a $1,000 bonus. The labor union has voted on which one to use, but different members of the union have different opinions based on the effect of the options that have on their salary. The union's leadership, which I should take over, has to determine which option is best for whom. Decide who benefits from each pay raise option by using the following numeric approach that involves looking at many salaries, high, low, and in between, determining the change. Oh my gosh, complete this table. Why do they have to make this so difficult? Wow. Wow. I would not do it this way. All right. New salary, 5% increase. So every one of these we're going to multiply by
Um,
1.05, right? So 15,000. This is going to take like forever. Oh my gosh. I'm a teacher and I'm complaining about this. So first one is 15,750. This is so unnecessary. 18,000 times 1.05. 18,900. 20,000 times 1.05. 21,000. 38,000. 40,000. 42,000. 46,000. 48,3. 55. 57, 750. 60. Yeah, I agree. 63,000. And I guess we're going to have to do this all over again, aren't we? 80,000. 84,000. 95. 99,000. Okay, now we get to do it by 3.5 and then add 1,000. You ready, buckaroos? There we go. 15,000 times 1.035. 15 525s and add 1,000, so it's 16,525. 18,000 times 1.035. 18, so 19,630. 20,000 times 1.035. 21,700. Boy, is this fun. It's almost as fun as watching you guys play baseball. Almost. I said almost. Uh-huh.
what do you want about baseball?
Well, I feel like it depends on where you're watching.
Are you on the team?
No, I was watching yesterday.
Were you?
Like in the beginning of the game, I was watching like right field. And, like, you can't tell what's a strike or what's not a strike, so it's like kind of boring. You know, if you're like behind the plate, you can actually really tell what is what. So
Right.
it's a little bit better.
So I can't watch professional baseball. I mean, my brother does it all the time. He loves watching baseball.
No, it's not fun.
It's just boring.
At Wrigley Field, yeah.
Even in Sox Park, I stopped going when my liquor bill got over $200.
Oh, well, that's like 3 drinks right
Yeah.
So you went the year they won the World Series. You went right before they got to the World Series.
Yeah.
Dang.
My brother was crazy enough to buy World Series tickets because he
Really?
wanted his kid to see a World Series in Chicago. So he spent the money.
I feel like they just drag those on just like to get more views and money out of
He paid like over 1,000 for him.
it. Or a game to watch on TV.
Right. Better and 10 times better view. Right. Okay, last column. Option one minus option two. Oh, that's fun. Option one. I don't know why we couldn't do this on a spreadsheet that we learned.
Well, I think it would make more sense personally.
750 minus 16,525 negative 775 18,900 minus 19,630 negative 730 minus 700 39,900 minus 43,330. What?
So the first time you type that.
Is that right? Yeah, I guess it is. Negative 430, 42. So this would be negative 400, negative 310. This one is not enough coffee. Negative 175, negative 100. We got 200, a positive here. 200 and a positive 425. All right, there we go. There's our tremendously time wasted chart. List the names of the employees who benefit from option one and those who benefited from option two. So option one, um, they benefited option one. They would have to be more money than option two. So uh, this person, Evelyn, and Emily, the two youths. What does the result in the difference column mean for John and for Emily? Well, here where's John? John?
Top one.
John means he took a pay cut of 750. And whatchamacallit, Emily? In general, which salaries benefit more under each options? Oh, come on. Let's see. The top one, two, three, four, five, six, seven, eight. The top eight people would benefit more. Okay, is there a salary for which the two options would be the same? I'm sure there is. Um, Only because I'm an algebra teacher. you would set their earnings equal to each other. And I'm cheating here because I don't want to do the computation. State the salary range of employees who would benefit more from each pay raise options. What does that mean? State the salary range of the employees who would benefit from each pay raise options. No, I'm not going to do the whole chart over again and figure out what the range is for each one of them. Nope, not going to do it. Hey, look at that, a spreadsheet. Read this. The calculations to complete the table by hand can be tedious. Then why'd you make us do it, right? Generalizing the calculation also allows us to make use of Excel. Imagine that. Didn't I say that? Spreadsheet. To create table of faster, blah, blah, blah. Although we can guess and check adding more original salaries. So, in other words, using what I said to use is easier. All right. Salesman starts the year with 200 clients and ends up with 260. By what percentage did his client base increase? So here you're going to do the change or difference, the difference of the original between the original and new. Divided by, let's see, they've got the original. Okay. So, in other words, the difference between the new and the old, see how they did this? That's what this is. This is the difference. That's your numerator. The difference is your numerator, and the bottom is the original price. Okay, so this is your denominator. Let's see if they got any example problems. And if it's an increase, just add the 100%, right? Oh, they do. Okay, determine the multipliers. Again, this is an increase of what? 37%, right? This is going to be a decrease, 100% minus 51%, 50%. So it's a decrease of 49. She's sleeping. She didn't have coffee, which is very understandable. Oh, another table. Uh, sorry. All right, husband and wife working together to lose weight after the first week. They weigh in and compare the results. Fill in the table. When completing the percentage column, use a calculator for the husband's information and scaling for the wife's. Okay.
The man lost more.
Starting, we can get through this today. Starting 380, ending 366. Pounds lost. It's going to be, let's see, 470, 14. Percent of weight loss, we're going to take our original 380 And we're going to multiply it by 100 minus 14, or 86.86. Should give us our. Oh no, we got to do percent. We got to use that other one. The difference of the original and new. Sorry, my fault. Difference of original and new is 14 divided by the original 380. 14 divided by 380, and it's a percent weight loss of 3.7%. Okay, wifey lost 10 pounds. So we're going to take 10 pounds divided by the original 200, and it should be 1/20th, or what's 1/20th is percentage? Isn't it 20%? 5%. Duh. And then these are just questions that ask specific, and I'm not going to go through them. All right, we're done. Emma, you're